This lesson is for FST, Lesson 4.1 on rotations and arcs. Students should always read the lesson, but especially in this lesson they should read page 223. I'm going to start to introduce the unit circle, and the unit circle has several layers to it. The first layer of which I'm sure students are fairly comfortable with, and that is using degrees to describe parts of the circle. When you go to certain areas of the circle, you're going to talk about them in degrees. Going all the way around a circle, you'd end up at 360 degrees total. Students who are either skateboarders or snowboarders are probably familiar with revolutions. Going around the circle one time would be considered one revolution. And then there's also a third element to going around a circle and describing it in length, and that would be called radians. In the past, students have referenced the length around the edge of a circle as circumference. Circumference and radians are very closely tied together, and we'll talk a little bit more about that in just a moment. So just to introduce the idea of revolutions and degrees, one revolution around the circle is the same as 360 degrees. It's also important for students to note that we all have to do some agreement on where we're going to start rotating or revolving around the circle and which direction we're all going to go. That way we're all consistent in terms of how we're describing which way we're going. So we're always going to start our rotations at what I would call 3 o'clock. We'll talk about why that is when we get into a few more details about the unit circle later on in the chapter. So we're always going to start at 3 o'clock, and we're always going to rotate in a positive direction, which would be counterclockwise. I don't know that there is a rational explanation for why counterclockwise is the positive direction, but I'm sure students can just go ahead and trust me on that. So if we're talking about rotating or revolving 2/3 of the way around the circle, we would all agree that the way that you would travel is starting from 3 o'clock, you'd travel around counterclockwise, and you'd end up somewhere in approximately quadrant 3. To figure out how many degrees that would be so that we know a little bit more exactly where we would end up, we would simply multiply by 360. When you have 2/3 of something, of always means multiply. And so we'd say 2/3 times 360, and we'd simply try to simplify that calculation in order to get an answer. It is possible for students to turn that into a fraction by putting a 1 under it. Students can multiply straight across if they like and then divide. My recommendation is that you try to simplify before you multiply. It just makes the simplifying easier overall. 3 and 360 have a common factor of 3. 3 goes into itself 1 time. 3 goes into 360 120 times. On the bottom, I know I'm going to get a 1. On the top, I've got 2 times 120, which is going to be 240. And again, that is in degrees, so we put the degree symbol. So 2/3 of a revolution is going to be the same as you starting at point A and ending up at 240 degrees. Your new location can either be labeled with another letter like B, or you could name it A prime. A prime symbol like that is what students probably used back in geometry, and we can continue to use that kind of labeling system. A radian measure, as I mentioned earlier, is similar to using circumference to talk about the edge of a circle. It's important for students to remember that radian measure is a measurement of length. So we're talking about the perimeter around the edge of the circle. Since our unit circle has a radius of 1, and students hopefully remember that 2 pi times the radius represents the circumference, 2 pi times 1 is simply going to be 2 pi on the unit circle. So going around the circle in degrees would be 360. Going around the circle in radians or in a length version, you'd be using 2 pi. So 2 pi radians is another way that we're going to talk about moving or maneuvering around the circle. One of the things that students will be doing in the homework is doing activity 1 on page 224. They ask you to complete this table in your notes and include all the degrees, radians, and revolutions. So students are going to be working through converting between all 3 of these, which I'll demonstrate shortly. However, I don't want students to make a table out of this information. We're simply going to do this on something called the unit circle. And the unit circle, remember, is simply a circle with a radius of 1. So there's a handout that students can get from me that looks like this. It's a bunch of concentric circles which we're going to use to help us memorize the unit circle itself. On the interior of the circle, we're going to put all of the degree measures. It's important for students to note that, just like we said at the beginning, we're always going to start at 3 o'clock, and that they have to imagine or pretend that this is indeed a circle. When it got drawn out on my computer, it ended up being stretched a little bit. It got to be a little bit more of an oval or an elliptical shaped circle. So imagine that it is indeed a true circle. And also know that these lines that were drawn here were not physically measured or accurately drawn, so we'll just have to use our imaginations here. So the first angle, or the first degree measure here, is 30 degrees. The next one is 45, and the next one is 60. So it is important for students to start to memorize, for sure, quadrant 1. The pattern here of 30, 15, 15, and then another 30 is going to continue all the way around the circle. So in quadrant 2 we will have 120, 135, and 150. And by the time you get halfway around the circle in degrees, you'd be at 180. I'd like students to take a moment right now and think about what the remaining values would be in quadrants 3 and 4. Quadrant 3 tends to be the most difficult for students, so I would like students to try to figure out for themselves what those 3 next values would be, as well as the one down here at 6 o'clock and all the values in quadrant 4. Students, go ahead and pause the video now and figure out those values for yourself. So here are those values filled in for you. What I've done next is also include on the next ring out the values for revolutions. The degrees are something that students will want to memorize, and it's the type of thing that you'd want to have your family help you with. So you'd want to hand your unit circle to a family member and have them quiz you on the different locations in degrees. Something you could teach them in advance is the different quadrants. So over here we're in quadrant 1, over here quadrant 2, quadrant 3, and quadrant 4. So you could have your family member ask you, what's the first location in quadrant 1? And you would say 30 degrees. Or what's the middle location in quadrant 3? And you'd say 225. It's very important for students to have all of those memorized and to be able to visualize them on their own. There will be an oral unit circle quiz given during Chapter 4, and it will be very important for students to know these by heart. The revolutions are not necessary for students to memorize. They will learn how to convert from degrees to revolutions, but since the homework has them calculating all of these, I thought we would just put them on the unit circle itself. We will be doing radians eventually. For now, I just want students to have a few of the radians filled in, and we'll do the rest later on in the chapter. Again, starting at 3 o'clock, you'd have 0 radians. All the way around the circle in radians was 2 pi, as we previously learned. So halfway around the circle would just simply be pi. Halfway to pi would be pi over 2. Going around the circle 3/4 of the way would be 3/4 of a revolution. Going around in radians, however, you'd have pi plus another half a pi, so that would be 3 pi over 2. So those are the only values that students really need to know for now. Let's go back to the notes. So students can go ahead and finish off some of those radian measures which we did not include on the unit circle today. They'll need those for the activity in the homework. So next let's talk about how to convert. When I do my conversions, I simply use this piece of information here. I already know that going around the circle in degrees is 360, and that that's the same as going around 1 revolution. And then I've just simply memorized that going around in radians is a value of 2 pi. Since all 3 of those are equal to each other, I use those and fractions to help me do my conversions. If students need a process for how to do this, I've labeled here the 3 steps that are needed. First, they're going to make a fraction out of the information given in the purple cloud. They're going to put the value that they want for the answer on the top of that fraction, and then you're just going to multiply and simplify. Know that for step 3 in this chapter, you're going to need to be good at simplifying fractions. Students who are not good at that are going to need to become good at that in order to get full credit. There are other ways to do conversions, and that's simply to memorize these 6 different values. I have found that that's very difficult for students to do, so I've modified the directions here to be what I've already indicated. So know that these values down here are just another way of doing conversions. We're going to do 3 examples here to illustrate how students are going to need to convert. So we're going to convert 100 degrees into radians. So the first thing I'm going to think about is, what's the relationship between degrees and radians? I know that there's 360 degrees and 2 pi radians in every circle. So I'm going to simply form a fraction out of those 2 values. My 2 fractions are either going to be 360 over 2 pi or 2 pi over 360. To decide which one I'm going to use, I look at step number 2. Put what you want for your answer on the top. So the radians is what I want, so I want the 2 pi over 360 as my fraction. Keep in mind that 2 and 360 are both numbers that have a common factor of 2, so that fraction is going to automatically reduce to pi over 180. So that's the fraction I'm going to use. So I have 100, I'm going to multiply it by pi over 180. When I multiply that straight across, I'm going to get 100 pi over 180. And now I simply need to reduce that. So some things that you can do to reduce quickly and easily is notice if the numbers end in 0. If they do, that means that 10 is a common factor. So I can simply divide both numbers by 10, which would eliminate a 0 from both. So now my fraction is 10 over 18. Both of those numbers are even, so I can simply cut them both in half, which would be the same as dividing them both by 2. So that would turn it into 5 pi over 9. Now I know that I'm finished because 5 is a prime number and it doesn't divide into 9 evenly, so I know that my answer is finished. The next question has you convert 1 radian into degrees. So I go back to my 2 fractions that I wrote before, and I know that this time I want degrees, so I want the 360 on the top. Again, the 360 and the 2 pi reduce to 180 over 1 pi. So that's the value that I'm going to use. I have 1 radian, and I'm going to convert it into degrees by multiplying by 180 over pi. If you multiply by 1, nothing happens, so your answer is simply 180 over pi. You could also divide that out and know that when you do, you get approximately 57.32 degrees. So know that you're going to need about a little over 6 radians to complete a full circle, which would make sense because we know that 2 pi is a little more than 6. Pi is 3.14. 3.14 times 2 is about 6, and so we need about 6 60-degree angles to make 360 degrees. So 1 radian is going to be a little less than 60 degrees to make it 1 radian. How many revolutions is 10 radians? So I need to make the relationship between revolutions and radians clear. 1 revolution is 2 pi radians. So I'm going to make a fraction out of that. 1 over 2 pi or 2 pi over 1. I want revolutions, so I want the 1 on top. So I'm going to take my 10 radians and multiply by 1 over 2 pi. When I multiply that together, I get 10 over 2 pi. I want to point out to students a common mistake that I see. Kids go too fast and they say that their answer there is 5 pi. Be real careful there that you don't make a careless mistake like that. Most kids know that that's going to reduce to a 5, but remember the pi is on the bottom. So make sure that you don't make that careless mistake. And then you would just say revolutions here, or you can just say REV to abbreviate it. It's important that students pay attention to the labeling because when no label is present, radians is assumed. So back on my conversion chart here, I should make sure to include degree symbols here on the 180s and on the 360s. A lack of a degree symbol will automatically mean that it means radians. So that's why the revolutions are labeled here. The 2 pi's are not, because those are in radians. The last item for the notes for today is the arc length formula. Typically, arc length formula is used for non-unit circle type word problems, and it's a very easy formula. It's radians for the angle times radius for a length. Keep in mind that this symbol, which I'll draw a little bit more clearly, is another Greek symbol, and the symbol itself is called or named theta, and theta stands for an angle within the circle. Keep in mind that that angle needs to be measured in radians. Remember that radians is a length. The R stands for radius, also a length. Keep in mind that the radius goes from the center to any edge, and the angle is some kind of angle that's inside or on the interior of the circle itself. But the actual angle is measured here on the edge. So we're taking a radius and multiplying it by the length on the edge of the circle. So a typical word problem that students are going to see are things like this example here. Suppose the blades of a windmill are 12 feet long. What is the distance traveled by a point on the tip of the blade as it rotates 4/5 of a revolution? So we're given a radius here, an R. We're also given a revolution, so our job there is to convert that 4/5 into radians. So that's the first thing I'm going to do, is take 4/5 and multiply by something to turn it into radians. Remember on the previous question I already had revolutions and radians in relationship here. I wanted revolutions, so I put the 1 on top. This time I want radians, so I would put the 2 pi on top. So I'm going to do 2 pi over 1, and I'm going to multiply across. When I multiply across, I get 8 pi over 5. This value is my theta. So I'm going to take 8 pi over 5 now and multiply it by the radius, which was 12. So when you multiply by 12, you get 96 pi over 5. If you divide 96 by 5, you get about 19.2. If you multiply 19.2 pi times 3.14, if you do 19.2 times pi or 3.14, you get about 60.3. Remember that this symbol here stands for feet. If there were 2 of those, that would be inches. So you just label your answer in feet. Always pay attention to what they ask you to round to. On this one they don't specify, so we can round to whatever we like.